Well, we're doing collaborative work with the Royal Vet College to try to understand how birds respond to disturbances in their flight, particularly gliding flight.
What I'm really interested in as an aerospace engineer is how birds deal with these complicated, really gusty, difficult to fly in conditions and how they do it so well.
The idea is we can use these experiments to understand and then extract inspiration for the design of unmanned aerial vehicles of a similar scale. For this experiment, we constructed a bespoke gust tunnel, or gust generator as we call it, which is a device that throws gusts of different speeds at the birds as they glide down our setup.
The way birds cope with that is to change their wing position and their wing shape, and the same for their tail, so that their head remains stable and they fly nice and smoothly despite very gusty conditions. And it's those movements of the wing that we're aiming to capture with 14 high-speed cameras and 10 motion capture cameras, which really capture every detail of every feather as they buckle, bend and are moved throughout these manoeuvres.
We get lots of different views from different angles, and with all those different views we can work out the 3D shape of the bird when they're flying. Once we've got that 3D shape, we can use it to generate 3D printed models like this one. So this is a small 3D printed model of Lily's exact shape in flight. We can also print larger models which we use for wind tunnel testing, where we can test other things that we can't do with the real birds.
Well, we've probably nearly all taken a flight which has suffered from turbulence. And part of the reason that it is unpleasant is because the aeroplane doesn't really respond in a particularly fast or practical way to reject the gusts that it's experiencing. Birds, on the other hand, are very good at doing that. The idea is that we learn from the birds about how they shape shift their wings.
And take our understanding of what the birds are doing and then see if we can use that to improve the flight control of our small unmanned air vehicles.
Then we might be able to get more agile flight, smoother, more comfortable flight, and probably fuel economy benefits as well.